will work. With
Which button? This button?
Yeah.
Let's find out.
Otherwise, we have no way.
Yeah, well, one thing at a time. Okay, should I start?
Yes.
Good morning. We can all take our seats. If we can all take our seats, please. Tom, we're starting. Welcome to 6-Man. I'm Bob Hinden. This is Ole Tron. We have a session this morning and also, let's see. So here's the note well. You should all have this memorized and tattooed on your arm. Barbara is taking notes. We still need a Jabber scribe. Oh, second note taker. Good. But we still need a Jabber scribe. Does Jabber still work? Eric, thank you. So we have two sessions. We did our usual thing of giving priority to working group drafts and then active drafts. And so we did this, generally the working group drafts getting discussed today and starting to do active drafts on Friday morning. Oops. And as you can see, so we have a lot of short talks in the end of Friday. We also have a follow-on session for the segment routing discussion. The plan is that the authors are going to be working with people during this week and then bring, hopefully, getting the document so we can do another working group last call on Friday. I think we would like to see this document be completed and move forward. And we also received a number of agenda requests that we didn't have time to schedule. And so we're listing them here and in the online agenda, and encourage the authors to talk about their drafts on the list, but you can also see them here and, feel free to read and comment. And I'll turn it over to Ole.
Okay, so what have we done on documents since the last IETF? We got 2 published RFCs. That's the IP6 node requirements, 8504, and we got the historical original simple IP protocol specification published as well as RFC 8507. I encourage everyone to read that one to see what the initial plan was for this protocol. We have nothing in the RFC editor queue. We have 2 documents in working group last call. They've been there for a while. The segment routing document since March 2018. What's the date today? Also, by the end of this week, they will be in working group last call for a year. That's probably a record. And then the router advertisement V6 only flag since September 2018. Both of those are on the agenda today. Hopefully, we can close these documents out and get them advanced. We have 3 working group documents. It's the ICMP limits document. Spoke to Tom, and he's going to refresh that one this week, I believe. That was just expired. We have the privacy extensions document, the BIS document for that. That's on the agenda, so we'll talk on that one. And then we have the Pref 64 document that was just adopted. That's also on the agenda. All right, so that was all for document status. Any comments on that? So there is an ongoing effort in the IETF to look at tooling and how to do document production more efficiently or differently. There's one ongoing experiment and some working groups using GitHub for documents, and we would like to look at that in 6-man as well, or at least initiate that discussion on doing that here in 6-man. There's clearly some great things about doing a source control management system for documents. You get sort of the same benefits that you do for source code, right? You get much better revision control. You get, at least we think you might get much more focus on editing the documents and changes in the documents. They would, appear as pull requests if you ended up doing this in GitHub, as opposed to sort of the meta discussions we have. Lots of discussions on a mailing list, lots of responsibility for the author to try to distill that into an actual document change. While if we were doing this, we think it would be easier at least to do a much more collaborative process. Of course, some of the downsides would be that perhaps the discussions wouldn't be open on a mailing list anymore. They would end up as sort of comments on pull requests on GitHub, which is a tool we don't control and might not be visible for everyone. But it's right.
And GitHub is currently not accessible with IPv6.
Yes. Yeah. So yes, let's discuss this. So Eric, you have a comment.
Yeah, a comment from Suresh, which is, as you know, removed this week, is supportive absolutely of this approach, as long as participants are not blocked by using GitHub.
Right. Yes, I think we have to, I suggest we do this as an experiment. Obviously authors will get to choose this themselves. So I put one of my drafts up there, and we started using it. Eric has posted a few pull requests that which I think worked well. Did anyone attend yesterday's session on GitHub tools? There was one tutorial there on Sunday. There's also a Thursday working group. Is it a working group? At least there is a session, yeah, on GitHub integration and tooling. And there's a couple of drafts here worth reading as well. And the quick working group, I think, has taken this the furthest, and they have, CI tools, and they verify the XML, and everything sort of builds automatically if you push a new draft. And you could sort of imagine that you could also push drafts in the future directly to the IETF, or submit a draft to the IETF website if you wanted to. So it becomes a new tool chain, but at least for what I've seen, just getting a different way of dealing with document edits is an interesting try. Any more comments on doing GitHub?
Alyssa Cooper.
Yes.
Just a note that the tutorial materials are all available, and it was recorded as well. So if people missed it, you can still catch up that way.
Yeah, cool. Thank you. So we certainly encourage people to try this out, and we might gently nudge authors to put things on GitHub as well. Thank you. So it is you, Bob. Go in the pink box and take the clicker.
Good morning. So I'm going to talk about the IPv6 only RA flag. I think it's Oli said it's in working group last call. So the changes since the last meeting, or in the new draft, and these were to address comments received during the last call, at least the author's view of this. So we added a host configuration option that controls whether the host should process this flag. And the notion is that unless this, unless it's enabled, the host will ignore, even if it's dual stack, it'll ignore this. The notion is, the concern raised was that if you're in an IPv4 only network, there's no IPv6 services, this could be used to turn off IPv4 maliciously. So this gives the site the ability to have it set so it will be ignored, so this attack, potential malicious attack, can't happen. And then, you know, in environments where they want to use this, the configuration flag can be enabled to allow this. And so we think this will help with the concern of using this to turn off v4 in a v4 only environment. We also, in this line, we changed text that the host can ignore this flag if it has active IPv4 configuration, say obtained from DHC. And so it's basically, if you have working v4, then don't turn off v4. It seems very sensible to do it this way. And if you don't have any active communications, then you should listen to the flag. We made some text clarification to improve, you know, what the administrator's intent was. We add Jorn as an author. He's made a lot of contributions and done the FreeBSD implementation. We updated the information on the FreeBSD implementation, and there are a number of editorial changes. Yeah, so at this point we have a FreeBSD implementation. There was some tests done with Scrappy to make sure if you send this, it doesn't break anything. And there's now someone working on a Linux and TCP dump Wireshark implementations. So as I said, I think the main issues raised were, you know, will be used by a bad actor to turn off v4 on an active v4 link. And so we think that the host configuration is one way of protecting, and that, as I said, you don't act on the flag if you have active IPv4. You know, if you just have v4 that's using self-configured addresses and there's no active connections, then you should be listening to this. And I guess the other comment is that the rest of the security issues are really the same as you have with all other control protocols that run on the link. They can all be used by bad actors to do the wrong thing. You know, you can turn off v4, you can break v4 with v4 just as well as with this. So we think this is, what's in the document is a reasonable compromise. We think the issues are discussed in the security consideration section, and so we think we've addressed these issues. So the authors think it's ready to advance. You know, we have implementations that show that, you know, it works and doesn't just seem to disrupt legacy v6 implementations. We think there's reasonable protections for the security issues that have been raised. And so we think this is ready to be advanced. So comments, questions?
Jen Linkova, Google. Yes, I think the document is really nice and ready for a publication. I have one comment or question, because I just realized I have a crazy idea of using this on dual stack network. So because currently the document says administrator must only enable it on v6 only, which I read as I cannot enable it on dual stack. However, there is a use case for this on dual stack when I'm trying to move most of the devices which are capable of working on v6 only to v6 only mode, and still allow legacy devices to get addresses via DHCP-v4. So I kind of see the use case for this to be enabled on dual stack. So do you think we can relax it to should in section 3?
I'm not sure, to be honest with you. I mean, we tried to make this be very focused on one thing. You're raising a different environment. So I'm not sure. I have to think about that.
Tim Chang, I would assume those legacy devices wouldn't understand the flag anyway, so it's really just a matter of wordsmithing the text, isn't it?
Yeah, that's a good point. Yeah, I mean, this only applies to dual stack hosts, obviously. If you have a v4 only host, it's not going to understand this.
Yeah, so that's the whole idea. All new devices will be instructed to move to v6 only,
Yes.
and all devices will stay dual stack as expected.
Right.
So it basically, I see it as a way to suggest, so as a suggestion to hosts to move to v6 only if they can.
Right. Yeah, and that's clearly not the way we were thinking about this, but I think, I have to think about it more, but I think it could be used for that. Yeah, so conceivably we could add some text, but I want the focus to remain, it is an IPv6 only link, and just we want to turn off the background v4 traffic. Okay, any other comments?
Okay. Just thinking quietly in my head here. I could hum to myself, yes. I'm not sure that's quite the process we want to follow here. Do we want to do a call on this further to determine the level of support to get this advanced?
Yes.
Yes. Okay. Let's do a hum on that. So the people in favor of closing this working group last call, advancing the document to the ISG, please hum now. And the people who are against, which would effectively drop this document and never talk about it again, please hum now. Okay, thank you. So, Fernando Gont, can you please come up?
Yes. In the box.
In the box.
Oh, you might want to say we'll convert to something else.
Okay, I'm Fernando Gont. I'll be presenting the RFC 4941 BIS document. And the idea for this presentation is to try to converge or close some of the issues that we have to agree on regarding this document. Let's start with the first one. In the current version of the document, we essentially specify two alternative algorithms for generating temporary addresses. One is essentially calling pseudo random number generator, okay? And the other one is essentially modification to the algorithm in 7217. Obviously, some of the arguments to the hash function are changed so that the algorithm doesn't generate stable addresses but temporary addresses. So the first question regarding this issue is whether, for example, we just recommend the simple randomization algorithm, whether we remove the 7217 algorithm altogether, whether we just include the description of both algorithms without recommending any of the twos, or any of these two, or some other option.
Yes, found. This is Christian Wittemer. There is a problem with using time for randomization. Is this thing working?
I mean, it is, but the volume is like.
Try to speak directly into the microphone, Christian.
Yes, like that?
Excellent.
Okay, fine. Yeah, there is a problem with having a concept of time in the generation of addresses, because in practice, you want your address to remain stable for some duration. And that's something we saw in MAC address randomization. That is good to have it stable, so that there are two notions of stability. Is that if you come back to some network that you visited 2 hours ago, it's often nice to keep the same address for various reasons. And at the same time, if you come back on the same network in a week, then it's not nice. So you have to work on this concept of what's the stable time that you want. Is that just, a Wi-Fi session? Is that a day? Is that, it has to be part of what you are trying to do there.
Well, in one of the next few slides, we are raising that question too, because there was the comment regarding of adding the the value of time or not. For example, let's say that you're just using a simple pseudo random number generator without any time parameter. If the algorithm is that whenever you want to generate a new address, you just select a new random number, then the question is, for example, what happens if you briefly disconnect to a link and then you reattach again? What do? You use the same address, you generate a different one, which is what I'm saying is that it's a more broader issue than just including the timer. The timer makes it evident if you want.
I'm not advocating a timer. I'm advocating having a discussion of this issue and balancing different solutions.
Okay.
For example, there's one potential solution to say that we don't use time at all. We assume the MAC address will be randomized according to some management algorithm, and then we use that. That's one possibility.
Okay. But I think that even if we remove the time parameter from the 7217, I guess there's still the question whether we want more than one algorithm in the document, have more than one and recommend one of them, have multiple, don't recommend any, just keep a single one and remove the rest. I'm fine with either option, but I just want to know what the working group wants to do about this.
Yeah, so please don't get up on the microphone line, everyone at once. Any host implementers of 4941 who cares either way? Or are you just going to stick with, thanks. Mr. Eric Klein coming up on the mic.
Yes, Eric Klein. I think I have a slight preference for at least keeping a reference to basically if you just use pure randomness to generate one each time as a possible option. I think the issue of what to do when you come back to a network is just some simple text about whether it's up to the operating system, whether they think they're trying to resume a session or whether they're trying to establish a new attachment to a network.
So you mean to kind of like leave it unspecified in a way, like, it's up to the implementation where to do it, when to do it?
No. Sorry, you're referring to...
If I understood correctly, like you were referring to the comment that Christian made, and you were saying that it would be up to the implementation, for how long the same address would be generated, because I couldn't understand properly.
Right. So it's up to the host if it's doing DNA, for example, right? Yeah. So if it decides I'm doing DNA, I've been in this network before within parameters that are operating system specific, it's okay to just attempt to reuse the address as you would with DNA, or not. It's up to the operating system, right? I would just add some text around. Management is separate from address generation, right?
Agreed. Now the question is regarding the algorithms.
Just make it okay to be purely random.
Leave it okay.
You can have as many algorithms as you want. Just let one of them be pure randomness.
Okay. So
you can have as many mix this with that and turn it 7 times and do whatever. Those algorithms are all fine. Just leave
So we
instantiate your Mersenne twister.
We keep the 2 of them and don't recommend any specific one of them.
That sounds fine to me.
Okay.
Thanks.
Hi, Fernando. Dave Blanca. I guess I want to also vote, or my preference is the single randomization. I'm sorry. Can you hear me? Oh, I was saying I'm also in favor of the simpler option of the randomization. One thing I wanted to mention, and I think you know this, and I'm not sure everyone does, but in MapRG in the last couple of years, we explored the possibility of, we noticed with privacy addresses that you can count, you can use the privacy address to create an estimate of how many hosts have a privacy address configured in a network, and there's some really nice advantages to that, and the randomization one enables that. The thing that you can do is try to guarantee anonymity to a certain size anonymity set, if I can count them. So I'm not going to go into the details now. We have a draft about it, and you can come to me afterwards about it if you haven't heard of this. But basically, if you use the straight up randomization with some fairly short-lived time, like the day that's in the RFC recommendation now, we can produce a high-quality estimate of how many hosts are there, and it aids anonymization for privacy. So that particular mode of operation has some advantages.
Regarding, and you'd keep the two algorithms too?
I really prefer the first, the one with the recommendation that it changes every day and that's a random number, or it could be any other time range. That's the version that has this property, not the one that when you lose the property when you choose a pseudo-random and you come back to a network and use the same pseudo-random again. If you believe that the next time you come back to a network that you will choose a different pseudo-random, that's the one that has this nice counting behavior that lets us guarantee a size of an anonymity set. So I'm just saying that's one of the considerations. If you think you're fond of the latter, I would like to hear, is it worth losing this counting feature?
Yeah, the thing is that, so there are two separate questions. One is whether we want to, remove the description of one of the algorithms. The other one is whether we want to recommend a particular one. So for example, if I understood Eric correctly, he wants to keep both and leave the option to the implementation, like, pick whatever you want.
Okay.
I mean, I'm fine either way. I'm just trying to figure out, what's the, what the working group prefers.
Yeah. I guess I'm in favor of even strongly recommending the former, specifically for this anonymization counting feature. If that's compelling to the community, I think it's a nice feature of the simple randomization mode that you can do this.
So I suppose we could certainly do a hum for each of these options. If we think people, well, I guess we could ask the people if they think they're ready to make that choice, or if we have to take it to the mailing list. I don't know. Any views on that? Are people ready to make this choice now, or do we want to take that to the mailing list? Well, we would confirm it anyway, but how many people have read this document recently? Okay, so we are going to take it to the mailing list.
Good.
But yes, let's talk about that, Fernando, and then we'll post these questions and get this closed.
Okay.
Thank you. And we would also like to have some reviewers on this document. Any volunteers? Ron? Fantastic. Christian, would you like to review this as well, since you've been involved in this for a long time? Super. Thank you.
Do you want to go to there are a couple of them
left. Right, sure. Yeah, continue. Sorry.
Yeah. Other questions for the working group. We had in a different ID a set of requirements for the temporary addresses. So far, they are not in 4941 bis. So there was the question whether to include them on the on this document or not. Essentially, rather than specifying, I mean, this is like something similar to what we did for stable addresses. On one hand, we had the algorithm, but on the other hand, we had like a set of requirements that the algorithm should fulfill. Like, the addresses should not be predictable, they shouldn't follow patterns, etc., etc., etc. So some have suggested to include these requirements in the body of the document. Obviously, we would keep the algorithms themselves. Others have suggested to include these requirements in an appendix. so that, if for some reason people wanted to use a different algorithm other than the ones that we are describing in the document, they know what are the properties that these algorithms should follow. I don't think there have been arguments against not including that, but still, I mean, I don't mind either way. The question is what the working group wants to do about it.
Any views on that? Come on, guys. Speed read the document and jump to the mic. Yeah. Okay, so we'll put that on the list as well. We'll start a mail thread on that.
Then there is another one, which is, this is a change with respect to 4941, which is the current version of the document makes temporary addresses on by default. What we think is that, in the light of 7528, that's a sensible thing to do. But, that's a change that is already in the document from 4941. But it's up for the working group to discuss whether somebody's against that.
What is 7528?
Pervasive monitoring.
7258, perhaps?
Could be, yeah.
Yes.
I got the number wrong then.
Yep.
Eric Klein. I mean, I vote in favor for on by default.
Sorry?
I vote in favor for on by default. We turned privacy addresses on in Android a long time ago.
Okay. I guess this could go as a question to the mailing list too.
Yeah.
And last topic, which is, some of the folks have made comments about this as part of the other question that I asked, is whether to add additional references regarding, when systems might want to generate a new address or not. One might be to point to, DNA for, folks that try to detect when they have attached to a different link or not. But based on the comments that we have received so far, it seems that, some reference to this might be of help.
Yeah.
So I guess that's it.
Okay. Any general comments, views?
Hi, Tim Chan. When you say requirements, are you talking about requirements from the host and user's point of view or from the network management point of view? Is it exclusively one or the other or both?
You mean requirements when I said the requirements for the algorithms?
Just in general in the document. So there will be no doubt requirements about when you think you should change IDs, interface identifiers.
Or recommendations, if you want. Like, one of the things that, one of the issues with 4941 is that there were, for example, implementations that they would change to a different link and they would keep the same interface identifier. So they might keep the same interface ID. So the question is, or the thing here is to recommend at least you should generate a new address at least, when these things happen.
Yeah, so part of that is about not doing it predictably every 24 hours exactly, for example. Part of it also, if you're managing the network, is ideally you don't want hosts generating more addresses than they need to establish reasonable privacy.
Yeah, I mean, in a sense, well, this is kind of up to the implementation, I guess. And there are a number of things that, will vary from one implementation to another when they want to generate a new one. There could even be situations in which, some operating system might want to generate a new temporary address for, some subset of applications. For example, generate a new temporary addresses for, web browser, could be.
Yeah, I guess the question is, are you just trying to do everything to maximize privacy of the user and then push the impact of that onto the people managing the network, or people like Eric who are trying to figure out whether that's a session that's recontinuing or genuinely a new attachment? I guess that's the question. Whether you have any views on that, whether we should try and capture that in the document.
I think it should, my personal view is that it should be mostly up to the implementation. up to the host. Of course, there is it's a trade-off, right? On one hand, host might generate might want, but we have the BCP about the availability of addresses. So in a way, if a host were to generate multiple addresses, it's within that BCP. I'm not saying that it's perfect, but it's a recommendation that we have right now.
Yeah, I mean, if the outcome is the host can generate as many addresses as it like, deal with it. That's fine. I just think maybe we can put some wording in there about that. Maybe maybe you think we shouldn't and just leave it completely neutral. If we're rewriting it, it's an opportunity, or updating it, it's an opportunity to move that trade-off slider one way or the other, or leave it.
I think that you raise an interesting point. I would say that probably if we, let's say, try to impose any kind of like constraints on that, which might benefit the network. On the other hand, we already have the BCP regarding the availability of addresses. So folks would say, well, we already have a BCP for that, and nodes are free to generate how many addresses they want.
Okay, thanks.
Okay, super. Thanks, Fernando. Would you mind moving this document to GitHub, do you think, or is that,
I have some on GitHub. I have some on GitHub.
Okay, right. So now we have a, 6-man or an IETF 6-man group on. Yeah, so that would be cool. I can work with you later on that one. Super. Thank you. Jen.
So far, an email saying you should be prepared to come up.
It's a pink cross now.
Yes.
Okay. Morning. My name is Jen, and this 10 or 15 minutes talk is about how you can discover NAT64 prefix in arrays. So I just resubmitted the document as a working group draft because it's been adopted. So let's go through the concerns which were raised during the adoption call. I hope I did not miss anything, so let me know if any of concerns are not on this slide. So first of all, first concern was we already have 3 different solutions to inform host about the prefix. But if we look at them, first, one solution is using DHCP, which is not suitable for Slack-only networks. Because basically the goal is if I have the network which using Slack to configure hosts, how can I provide hosts with NAT64 prefix in secure way? So DHCP is not an option here by definition. PCP basically is the same, right? Especially if the hosts are uncontrolled, I have no guarantee that host supports PCP. And if the only thing I used for configuring host is Slack, I have actually no desire to turn on additional services, especially if I don't know if clients are going to support it. So this left us with RFC 7050, using DNS to discover NAT64 prefix. The obvious problem with it is it has some security implications because you kind of have to trust DNS answer, which can be easily spoofed. So obviously it still could be used by legacy hosts, but what we're trying to do is to provide host with NAT64 prefix in more secure way, and also in single packet. Host could get all configuration information instead of waiting for DNS exchanges. So, well, other concern was the proposal.
Do you want to take some question in between?
Sure, sorry.
Yeah, okay, so just if we...
Name, please.
Mohamed Boukader, Orange. Yeah, so let's assume that is true. So if we... Mohamed Boukader. So
sir, you need to get closer to the mic.
Yeah, so I will try my best. So sorry for that. Okay, so if we assume that the information which is in the slide is true, that means that for every service, we will have to apply and to give this argument as an argument to define a service option in array. So it's not secure. So I need to define some, for instance, for my DSLite CGN name there. So I have to be able to define an array option because of this argument that you are providing here in this slide. So thank you for that, by the way. And then I need to define, for instance, a SIP proxy server. Then I have nothing. I am only running Slack only networks, and then I have to go to the same arguments, and then we are, I would say, repeating the same arguments and again. So I don't think personally this is a good argument to justify why we have to define this new option in arrays. So if we give it as a fact, then we have to open the door to any service name to be defined in the array option itself. So that's only a comment about this one.
Let me answer this. Slack is designed to provide hosts with configuration information which is needed for basic network connectivity, right? I am not aware of any operators who think that all their hosts need to be provided with SIP proxy to get basic network connectivity, while DNS 6.4 and NAT 6.4 and v6 only network is basically required for hosts to have internet connectivity. So it's kind of special case. If in future we see any other use cases for something else which is required for the host to operate, we might consider, I believe, other array options, but I think we're doing it on case-by-case basis. I have a use case when my hosts need to be provided with NAT 6.4 prefix, otherwise they could not access the internet reliably. So that's why I'm suggesting using array option. I don't need to configure SIP proxy.
That's your take. You, as an operator, you can, but the other operators can decide that you want to have, for instance, to be able to provide some specific services to their IPv6 host using Slack, and you cannot mandate to the other operators how they can do it just because for you don't think this is a basic service. I think this is where which is really, I would say, a gray area, which is we are starting. Either we allow it for every service, or either we are really careful about that. But anyway. My main comment is it really about this kind of list in here. So I really don't care if we just start and define a new option for array and for NAT64 and so on. But my main concern is that there's already there an IETF consensus document. We have went all of these options, and this is a déjà vu solution, and we discussed the error option and so on. I was not against it at the time, but the IETF decided to go one way. And if we have to revise that consensus document, we have to obsolete the existing RFC, which defined all and made a recommendation for the IETF as a whole. And we cannot do that separately for the specific case. But by the way, the discovery of the NAT64 may be important for some cases, but there are some networks in which they don't need to discover the NAT64 because the NAT64 is only a service. Providing the IPv4 service connectivity is not a mandatory requirement for every IPv6 network. You can require it for some network, but this is not something which is mandatory for every IPv6 network. That's okay. Only for this one.
Sorry, may I ask you two questions? So first of all, are you suggesting that we need to update some of the other RFCs with this? Because I assume whatever IETF decides could be reconsidered in the light of new operation requirements. So that's why we are coming with this solution. And a second question is, we have other array options like more specific routes and DNS and so on. Shall we also stop using them because we have other ways to provide the hosts with that information?
Yeah, I think that's the point here is to be fair for the people who made the effort in the past and made that recommendation and to have a consensus. Just by the way, for information, for the DHCP, for instance, it was not recommended as a solution. And we have the opportunity in the past in the DHCP working group and the software working group to define a dedicated option for NAT64. But me as an editor at the time, I said no. We cannot split the option because we will have a side effect that will be a way to configure the NAT60 option, and this will be against the existing IETF recommendation. So if we will start to do this work, just start to do it in the right way. The right way for me is to go and try to obsolete the RFC 7050, and then with the new information we have today, and to explain to the IETF why we have to obsolete that recommendation and why new solutions need to be defined. That's the point.
So our AD, Suresh, he is unfortunately in India. He's in the microphone queue, so I'll let him interject if you don't mind.
Okay. Hey, can you hear me?
Suresh, you should be on.
Okay, I'm not moving at all in my room. I'm sitting in a chair. So just to.
So Suresh, can you move a little bit further away from the microphone because the volume in the room here was very loud.
Okay, how about
you
now?
have full control.
Okay, like I'm really like holding my mic like as much front of me as possible. So there's something in the room. But the thing I wanted to say is, whatever fetch shares with the router should send stuff in arrays. And the DNS and NAT64 are border cases. So Med was saying next, what is next? Like the SIP server, like that's obviously not going to happen. Okay, so this is like somewhere in the middle that we can consider discussing it, but I'm not sure either, to be very frank, Med, right? Like, where this falls. But so the as far as like obsoleting 7050, I don't think it's a necessity. Like we do have some examples where like we have duplicate stuff. Okay, so I'm getting quite a bit of feedback myself. Okay, I think I'll just type and let somebody relay.
Yeah.
So Eric Ving speaking for Suresh, and basically from the Jabber room. So,
Closer to the mic.
Microphone.
Okay, we'll get the good average, I guess, at some point of time. So it basically says, Suresh view, that if the configuration information is fetch sharing with the router, it needs to be into the route advertisement. If not, it can be in the HTTP. And then DNS64 and NAT64 are border case that can be argued whether they are basic connectivity primitives. And I don't think this will extend to SIP server.
This is Dave Faber, trying to speak into the mic. So on the topic of 7050, I think that it does not need to be obsoleted or whatever. I think they're actually for different use cases. I think the use case that you're targeting is the one where you're configuring the router and you want security and you have secure RAs deployed, right?
Kind of.
I don't know how many people actually have secure RAs deployed, but 7050 is for the case where the organization that deploys the NAT64 and DNS64 may be under a different administrator from the one that's configuring the actual first hop router. So if you think about like a tethering case or something like that, where you're the local router on your phone or whatever, and so 7050 works regardless of whether the last hop router has any knowledge of it, right? Because you're getting it from entities that are where the NAT and DNS server are. And so I think that they're for somewhat different deployment cases. One where you specifically have security turned on, which is the case where you're using in your RAs, and where you want administrative control at the edge router. The other one's for a case where you're controlling stuff, where you're the entity that only controls stuff at the DNS64 and NAT64, which may be farther away than just the last hop. And so my point is that since neither one is a superset of the other, it doesn't make sense to do a obsolete. They're actually for somewhat different use cases that they're both valuable.
Yeah, fair enough. By securing array, not necessarily means send. I mean, I can guarantee that my host receiving arrays only from my router to some degree, right? So I can prevent rogue host to send arrays. So I can say, yeah, my arrays are reasonably secure. And if I have someone sending malicious array, I have bigger problems than NAT64 prefix discovery, right?
If you don't have send, then how is it any more secure than 7050? As I think right now, 7050, you're saying C secure, right? Because it's not secure in that sense. Well, neither is RAs unless you have send.
I cannot guarantee that that malicious host is not sending spoof DNS response from outside. While for arrays, if I isolate host to host and traffic is only allowed from host to router, I can guarantee to some level of confidence that arrays are secure.
If you can prevent host to host, then I claim you can prevent spoofing of DNS from other
DNS
hosts on that link.
From outside. It's not necessarily from inside the network, right?
Okay, I understand your answer. My point remains that I don't think either one is a superset of the other scenario, and so it doesn't make sense to do an obsolete.
Yeah.
Eric Klein. Yeah, in a sense, the RA option allows you to not have to have DNS 6.4 at all. That's the point. So if you have lots and lots of DNS over TLS or DNS over HTTPS or some other things, and you can actually have the host do DNS 6.4 synthesis on device and not have to have not have to talk to a DNS 6.4 server.
Yeah, thanks,
So
Eric. It's a very good point, which I think we forgot to mention on the slide.
That's the way
Eventually, I can
it's-
get rid of DNS 6.4 completely. If hosts are able to deal with not with the prefix themselves, I do not even need to run DNS 6.4.
And yeah, in fact, that is part of how it was sort of discovered, turning on private DNS.
So yeah, another concern raised was that it should be configured on the router, which is operational nightmare. And I kind of disagree because we already have to configure prefixes for Slack, DNS services, preferred lifetimes, and other things. And normally automation take care of this, so it's not a bug, it's a feature. So we can allow all that information to share fate with routers because it's directly related to routing, whereas this NAT 6.4 prefix is going. So obviously, I do believe it makes sense to share fate with router information. So it was some concern raised about let's unify the HTTP v6 and array options. To be honest, I did not really get it. And anyway, I believe it's kind of out of scope of this draft. And if we start doing this, we can have another conversation about this. But to be honest, I just like to let my hosts in v6 only network to get prefix and see implementation as soon as possible. So we received a number of suggestions for the document. First, Mark, adding exclude set for v4 ranges. Honestly, I kind of think we should be doing this, but probably not in this option. Because again, this option is mostly useful in v6 only network. Exclude set would not be really useful in v6 only scenario. It would be useful in dual stack with DNS NAT 6.4 network. So probably we just can have another array option, and I'm kind of volunteering when I write a draft if you think it should be, we need this option. So non/96 prefix support. We've heard about one use case, have not heard about others. So first question, shall we be doing this? And if yes, how? Because the current proposed option format is trying to kind of minimize the size of the option. So we're not inflating array too much. So we came up with two ideas of how you can support non/96 prefixes. First of all, obviously, is just add prefix length in the top, which unfortunately means you significantly increase the size of the array, always. So even if you use /96, which I suspect will be the most common use case, you still have a large array option. Another slightly more crazy approach is to have prefix length at the end. And if the option length is 2, then you know that it's /96. And if option length is 3, then you get the prefix length at the bottom of the option. The benefit of this is that you basically do not need to have large option if you use /96, so you can save some space. And I think we have precedence with route information option, which is also variable length, so it's not something so uncommon. I actually do not have any preference, so I would like to ask to see a working group opinion on this. And another option is, yeah, let's do /96 now, and if we come up with operational use case for non/96, we can do that, or use always a universal array option for this. So we just resubmitted the document as a working group draft. Main changes, we clarified why host might need to get DNS NAT 6.4 prefix. For it's a local DNS sec validation, 464 XLAT, using IPv4 literals, using trusted, untrusted external DNS servers, and also, as we just mentioned, eliminating DNS 6.4 whatsoever, because eventually, if I know that all hosts support this option, I don't even need to run DNS6.4 as a separate service. And it was some confusion apparently in the text about why we're saying that we using only one option, one prefix for all destinations, and at the same time the option might appear more than once in the array. So we clarified the text a bit. Hopefully it's more readable now. And so now I would like to hear some suggestions, options. We need coffee.
Mark Andrews. The excluded addresses, if we go down the variable array length path, adding the exclusion information could be optional. And we could do exactly the same thing as you're doing with length. You have a prefix length, and then after that you have a DNS address where you pick up the information from for the exclusion information. You don't have to encode the exclusion information in the option itself. You just need to have a pointer to where you can find it.
Well, so
and basically you'd have prefix length and then a DNS address encoded in a DNS wire encoding with the root saying there is no address, there is no information. So you get prefix length and one more byte if you've got no information, or if there's no information and no prefix length, you do the short array.
yeah, actually, yes, that does make sense. Yeah, so basically you're suggesting that we using approach number 2 and we expand this to have some other additional information which will be optional. If you don't, yeah, fair enough. Yeah.
Hi, Martin Huniek. I would like to ask one thing. Is the option able to transfer through, for example, CPE? Because I do have a similar draft which solves the issue differently, and I've been getting this question. If the option is able to transfer through, for example, router. Because if you do have a provider which which gives you this option of the prefix for 6.4 or not, if such a device after the CPE would also receive it.
So I guess you're suggesting that the CPE should, if they receive it from upstream, they should include it in the array send downstreams. Yeah, I think it should. Yeah, we can add the text clarifying this. Yeah.
Okay, thank you.
Andrew, you wanted to say something, no?
I didn't really have anything to add after you responded.
Okay, thank you. Well, so this has just been adopted, so I guess we'll enjoy some more working group.
Next version.
Yes, thank you, Jane. Okay, Darren, are you here? The floor is yours, and I think you have 30 minutes, right? Oh. That one to that box. Yeah.
Okay, let me see if we can get the mic the right height here. Can everyone hear that? We're good? Louder?
Closer to the mic.
All right, you know what? Let's take it right out. There we go. How's that? Okay. All right, so the SR header revision 17 was attempted to publish, and it's just finally published now. You guys can see it. There's been some updates done to it. So we're going to cover what's in revision 17 in this talk. Once again, thanks to all the collaborators and partnerships we've had, the vendors, the service providers, the members of this working group for commenting and contributing to this draft. Today we're going to cover 4 major parts. We're going to cover running code and deployments. That's our kind of main objective of this working group, is to get closure in drafts and get running code and get a rough consensus within the working group. So hopefully we're well on the way to getting that. And with the changes in revision 1617, as well as the issues that we need to close this week to complete the last call, and we'll cover how we plan on doing that this week. All right, so on the SRv6 collaboration adoption, we've had quite a number of years. I know this, you mentioned it's been in last call now for 12 months. We've been 6 years since this was first presented at the IETF. There's been, like I said, lots of industry support and vendors and academic research. There's been 24 revisions of the draft. There's been 1,000 emails approximately on the 6-man mailing list from a basic search. I think that's 1 email per line of text, or very close to it. There's been a large number of IETF presentations, and 35 versions of the draft have been submitted since it was an individual submission. There are a lot of implementations, so I'll go through them relatively quickly. These ones I think everyone's well aware of. I've talked about them before in 2017, and then ongoing updates to Linux as of 4.10, Linux SR extensions, and FDIO VPP with SRv6 support in all 3 of these, including what's in the SR header and beyond. Cisco has shipping code with the SR header on the ASR 9000, 5500, a bunch of iOS XR platforms, and that is shipping today and shipping now. Huawei has a large number of shipping products with SRv6 support as well on their VRPV8 platforms. Barefoot has shipping code since I believe May of 2017. And I believe there's actually an open source reference I can post to the list after this talk for the P4 code on Tofino. Spire and Nixia have released SRv6 support on their hardware implementations. All right, on the application side, we have Wireshark, TCP dump, IP tables, etc., Snort, NF tables, all with SRv6 support released for them. We have an eye chart of research publications on SRv6, everything from some very cool load balancers to some SDN architecture for networks, some enterprise use cases, basically lots of stuff there. You can take a look at the presentation offline and browse these as much as you want. There have been interop in 2017 for L3 VPN with traffic engineering and service programming between FDIO, Barefoot Tofino implementation, Cisco's NCS 5500, which is using a commercially available NPU. So other platforms other than just Cisco's can be building SRv6 solutions based on that. And the ASR 1000 family using a custom Cisco ASIC. Again, at NTech 2018, there was L3 VPN with traffic engineering and TI-LFA that was interop tested between the NCS 5500 and Stratacom, Ixia, and Spirent. Release-wise and deployment-wise, SoftBank, of course, announced their nationwide SRv6 core network utilizing the content of the SR header draft, a bunch of services that are in network programming beyond what we're working on here, extensions in ISAS and BGP, along with ping and trace route support from the OAM draft that's going to be presented maybe later today or Friday. China Telecom has deployed a nationwide network on SRv6. No, I said nationwide, but an SRv6 network on China Telecom utilizing this draft again, some of the functions out of SR network programming, and again, SRv6 extensions in BGP and ping and trace route support. All right, so that's the end of implementations. All right, I suppose if we're going on on what's been developed, what's been deployed, what's been released. There's a lot of investment on this draft from vendors, from service providers, and it's been, I think, fairly well deployed so far, even though it's still perhaps early in its life. So let's take a look at changes in 16 and 17. The deployment model in revision 16 was updated, really to concentrate on how we secure the SR domain from external attempts to use its SIDS. We looked at the SR domain as a single routing system with delegation between components. That includes some description of how HMAC can be used in that system. And we described how packet handling happens within the SR domain for ICMP errors, for MTU, for AH, ESP. So it's pretty well described now in the deployment model as of revision 16. Revision 17, we've removed the reference to network programming that was asked for by some. One of the open issues, or I think two of the open issues were on that. TLV processing limits were added. This was, again, to start to address another TLV-related issue that we have in the issue tracker. There may be more work to do there, but we'll see this week, and we'll see from comments that people have. We've had some updates to pad TLV, some minor descriptions, made sure HMAC is covering the destination address of the packet and that it matches the first segment. The extension header processing rules were updated to make it clear that extension headers are in fact processed in order and we're not skipping any of them. That apparently wasn't clear in the previous revision. I think there was some confusion on that. And flow labels are required in this draft for intra-SR domain communication as well. So previously we had flow labels required for inter-domain. This draft adds them for intra-domain. There's a section that I think Adrian somewhere here had pointed out a while ago that we needed, which was more description around what a designated expert is supposed to do when assigning, making assignments out of the IANA portions of this draft that are specified, the flags and TLV. The description in that section now follows the best practices in 8126, so requires a working group draft and requires notification to 6-man, and describes what sort of time frame is required and how the expert reviewer should respond. All right, issues to close on this draft. We still have somewhere around I think 10 or 12 issues that are remaining open. Some are duplicates, some are partially closed, and some of those are actually fully closed, so we just need to do the housekeeping to clean them up. However, on the tag processing, I sent an email out to the list this past week on this. Tag processing, I guess, as it's defined in the draft, the processing is defined at least saying that this is how a source and endpoint node should be handling it when we don't have a use case defined. We don't have a use case defined in the draft, and looking at how to actually document in this draft what those use cases might be and how the tag field might be used was going to be a fairly large amount of information to put in here. We think that it's still better to leave that to a separate draft to define various use cases and how that tag would be used to identify a group of packets at the source for processing at some segment endpoint. On the TLV side, the TLVs are really that fundamental part of the SR architecture where we want to get that integrated underlay and overlay and service chaining solution implemented. And we need to be carrying metadata along with some of those segments. The TLV provide a space for that metadata. And it's important that we include that space within the SR header. If we have it preceding the SR header, we run the risk of expanding the number of bytes that need to be processed on some of the topological segments to the point where we reduce the amount of topological segments that we can process, or we increase the processing requirements on those topological segments that have to parse those TLVs. So in keeping them included within the SR header after the segment list allows us to basically not process them or not skip over them until they actually need to be used. On the management section, this was something back at IETF 103. I noted that we wanted to take a look at. I think at the point where we're at now, we don't have a management section defined in this draft yet. And we don't have any example text on what that might be. It's probably a good idea at this point to leave that for another document to describe any additional management requirements around SRv6. I know there's various Yang models that are coming out for SR policies. So we can talk about that. Folks can give their opinion, but I think it's probably best at this point we leave the management section for other drafts. Okay, then the plan on how we're going to close last call. So we've been asked this week to get this document closed. I've requested meetings with folks on Tuesday and Wednesday, the folks with open issues and issue tracker. There's a couple that I haven't heard from yet, so hopefully I'll hear from those folks today and we can get on with those meetings. I have a meeting set up with Bob on Thursday to go over the state of those issues from Tuesday and Wednesday so we can make any updates to issue tracker. And then be ready for Friday's report of where we are with open issues on the SR header. Okay, and that is our current status of the SR header in the working group. So go ahead, let's open it up to discussion and comments.
Eric Nordmark, question on your implementation list. So do you know which subset of these ones actually do encapsulation as opposed to the old non-encapsulating in inserting of the SR header?
Okay. So all of these, all of the implementations are VPN implementations. They all encapsulate.
Okay.
Yeah. All right, there's got to be more than that. We've got lots of time left.
Yeah, plenty of time left.
Tom Herbert. So
Hey,
with
Tom.
respect to the TLVs, there's actually two questions, I think. So one is, why are TLVs required in the segment routing header as opposed to using, say, destination options before the segment routing header? The other question is, if you do have TLVs in the segment routing header, why would the definition and the requirements be different than hop-by-hop options or destination options? So for instance, one of the big differences is that there's a modifiable bit. However, in the segment routing TLVs, the type and the length are not covered in a modifiable bit by the auth header. They're zeroed out. That's very different from RFC 8200. So I think the implication there is, and this is probably something that has to be closed, I think at one point there was the idea that segment routing TLVs could be inserted or deleted. And it's unclear from the current discussion, is that something that is intended or if it's eliminated? If we're never going to do that, then I don't see any reason why the segment routing TLV should be any different than hop-by-hop or destination options.
Okay, so let me see on the first one of those questions, which was why have TLVs within the routing header versus destination option. So there's two answers to that. The first answer, the technical one, is TLVs that precede the segment routing header, push it back further in the packet. As we add more TLVs to the basically preceding that segment routing header, those nodes that are simply let's say topological processing nodes for the most part have to look further into that header to process the segment routing header. and have to do additional work as they process that segment routing header. They have to walk each one of those destination option TLVs. With the TLVs within the segment routing header, that's not a requirement on every segment that's listed in the segment list. Okay, so that's the two of them. That's the first one. The second one, that's the technical reason. I think more of the design reason is that well, when you're defining a segment list and you're defining I guess the source routing as a solution, keeping the segments and the options associated with those segments in a single extension header is I guess attractive in that regard. But combined with the additional processing overhead, I think that's a significant reason to keep them where they are in the segment routing header. Joel, you've got a follow-up
Joel
question.
Halpern with Ericsson, a question on your most recent comment. I don't see where the current document draws a distinction in kinds of segments, much less says this kind of segment must look at TLVs and this kind of segment must ignore TLVs. Mm-hmm. You may have implemented it knowing what was safe, but that's not an interoperable implementation. Saying there was a shortcut you could take doesn't help us. So I'm really concerned by this.
This document only defines the header structure and it defines a single type of segment, an end segment.
But the processing rules for TLVs have to be defined here. They can't be added later. You're justifying putting the TLVs here technically on the basis of processing rules, which are not here. I can't see how that can be a justification for including the TLVs technically. It's not here. You're not spelling it out. How can it be a behavior that drives the design?
Okay, so again, this draft is designing the base that other things are going to be built on. Obviously, it's not. Obviously, every conceivable use case is not spelled out in this draft.
No, but
right?
the question
We're
of
defining
which
the
things
base.
must process TLVs and must not process TLVs does seem to be a base behavioral requirement.
Yeah.
And the implicit current text is everything must look at them. Not everything must do HMAC processing, but it has to notice it.
No, actually, the current text in the document says dependent on local policy, which is open to further clarification in subsequent documents as to what that would be.
It doesn't
they would
lead
look
to
at
the
the
optimization
TLVs
you're
and they
citing.
would look at the HMAC.
It doesn't lead to the optimization you're citing as the excuse for doing it.
It's okay.
Okay.
I think I described the technical reasons why fairly clearly.
So Satoru-san, do you have an answer to
TLV things?
Okay.
Yes.
So actually, in the other SDOs,
Closer to the mic, please.
Sorry, Satoru Matsushima from SoftBank. Other SDO consider the SRH only user plane specification, so that the TLV defined in the SRH is very useful because the entity of the user plane forwarding defined in the other SDO like CGBP consider a study to put the some parameter in the as a metadata in the server header. So this is our principle to study the other candidate of the user plane protocol. So, yep, the processing TLV is could be defined in the entity of the that user plane. So the confine the order of the metadata in the search is the absolutely our option. Thank you.
Okay, so the Right Honorable Jabberscribe.
Yeah, so Jabberscribe speaking for Michael Abramson. He asks you, Darren, can you elaborate on the MTU discovery you just mentioned and where to find information in the draft?
MTU discovery?
Yep.
I don't think I mentioned MTU discovery.
MTU handling?
I don't recall saying anything about MTU. Did I? Okay.
I'm just repeating the question.
Okay, yeah, I understand, yeah.
Cheng Li from Huawei, and I have two comments. The first one is TLV in the destination option header has the same functionality with the TLV in SIH, But actually, for me, I think that if we put the TLVs inside the SRH, which is beneath the segment list, would be better for hardware processing, right? And the second one is actually we have several implementation already, and our customers require SRv6, and we hope the authors to address the issues as soon as possible because it's a long term. Yep. Thank you.
Right. This is Zafar Ali. So coming back to TLV, I have a draft which is would be on the agenda hopefully today. But just to add what Darren said, when to process TLV is a property of the set. This is the notion of programmability of the network. So let's say, for instance, the in-band O&M use case that is there in the draft, it allows more flexible implementation that all nodes along the path doesn't have to look for the TLV. Based on the local SID, the node knows whether to look for TLVs or not, which is the true notion of programmability. So it goes back. So if we go with destination option or hop by hop option, you lose the entire basis of SRv6, the programmability aspect and efficiency aspect. So in addition to the hardware efficiency, there are network-wide efficiency. And there are many use cases, and in-band O&M is one of them, where we can take advantage of it because not all nodes in the network are capable of processing TLV. So when you send an in-band O&M packet, only node that are capable of doing so needs to look for it and needs to modify it.
Thanks, Far.
Tom Herbert again. So on the subject of local policy, this is used several times in the draft. And in some cases, it's very open-ended, like it's up to local policy how to process TLVs in certain cases. And the thing is, that's so broad that it's almost like an implementation could decide to process these things however they want. It's an unlimited, open-ended thing, which makes me wonder how you derive interoperability and conformance from that. So I think in the draft, I personally would prefer to see configuration as opposed to local policy, where you have maybe two choices. You can configure it this way or this way. But the open-ended local policy and the comment that we're building this on the assumption that there's going to be things later that further define or clarify that, I think, going back to the previous points, we have to have in the draft, it has to in a sense be complete such that I can implement this without having to make assumptions or guesses about what the right local policy is.
Yeah, so I'd say at this point we're not making guesses. There's a number of drafts already that are defining TLVs and how or when they get processed. So that's beginning to happen, and the involvement of this working group and the spring working group in those drafts will shape
Right.
will
But
shape
they
the
should be
rules.
defining TLVs in the framework of what TLVs are. And my claim is the definition of TLVs themselves is still open-ended, so somebody could come up with some alternatives that no one else would ever implement, but it still claim conformance. That's the issue.
Robin from Huawei. I think now that's the more discussion regarding the TLVs in the SRH. In fact, we already proposed some of the use cases in other draft. That's the SRH TLV is useful for such use cases. So my suggestion is that because these use cases depend on the SRH draft, instead the SRH draft depend on the possible use cases of the TLVs draft. So my suggestion, since that's the use cases justify the TLV usage in the SRH header. So my suggestion is that this draft is just propose the definition of the TLV in the SRH. But for the problems of the TLV, for such the use cases should be in the DOH or the hop by hop header or the SRH TLV. I think that can be addressed in the use case of the TLV's draft. That's my comments.
Okay.
Hi, Darren. Ron Bonica, Juniper. This discussion about TLVs and destination options could go on for a very long time. And the reason why is we're making design decisions based on poorly understood requirements. Right now, we know about exactly one TLV, the HMAC, and we're not quite sure we understand that completely. Maybe a good thing to do would be to leave the door open to doing it either way later when we understand more TLVs and more requirements. Leave the door open for now, move them out of the document so we can progress the document and get it as an RFC, and reintroduce it when we know what TLVs we're actually going to use. Does the SFC TLV belong in there? We don't know yet. We're 6-man guys. When we understand it, then we bring it back and we put it in the right place.
Okay. I would think I would certainly think that defining it now and defining the base now and allowing for that innovation, those options to be brought out is certainly more valuable than saying nothing on it.
All of us have an interest in getting this document published quickly because we really do want implementations coming out. To get it published quickly, the best thing we can do is put off the controversial decisions and publish what we all agree on.
No.
I like, this is Zafar again. I don't understand this, logic. Like, this is like, everything is spelled out in this draft, and there are so many use cases drafts that are there. Then claiming that we don't know what is the usage when there are implementation that exists for using those TLVs makes no sense to me. And with all due respect, Ron, there's a point where we have to differentiate between political interest and the actual reality of the world. This work has been going on for 6 years, and this discussion has been going on for more than a year about this TLVs. And you seem to be stuck with this, and you seem to be always claiming remove, chop, where everything is properly defined. I think you have to be reasonable.
I'll ask how many TLVs are defined today.
Sorry?
I'll ask how many TLVs are defined today.
There are TLVs defined for IONM, inbound ONM. There are
in this
TLVs
document?
defined, no, in a complementary document, which references this document.
So if
HMAC
you
is
look
defined. HMAC is defined. Okay, let me finish. And this is placeholder for TLV. This is not, okay. And then there are TLVs defined for service chaining, performance management. Robin,
how much has this working group seen?
Robin talked
and
about
how far
the
advanced are
TLVs.
those?
Okay.
So if you were to use the same logic, then destination options would have never been published in 2460 because there are exactly two TLVs there, pad N and pad 1, right? Like there was no TLVs there defined either. So we define these things so that we can build on them, we can build product on them that is useful to the network, and it's useful to it's useful in deployments, and that's we define the base, and we allow the innovation to happen on top of that. I think that's what Safar was calling out, is that there is definitions that are being built and in different drafts and coming out now.
You're asking to do the design process backwards. Let's design the packet formats now, and we'll agree on the use cases later.
Ron,
well, okay, you don't know all the use cases before you start. You know some of them. You've got a good view as to where things are going, and you make the best engineering decision you can with the information that you have. You take one step forward, and you keep taking another step forward and another step forward until you get close to that right solution. Right? And that's where we are. We're taking one step forward.
Robin Huawei, okay. I already mentioned, I think this is not the task of the draft to defend all the possible TLVs of SRH. I think that is, I already, Darren mentioned this, the design of this, the purpose for the TLV. I think that's the first is the integrated of the solution for the SRH. So that's the segment, and also this the segment list and the TLV can be incorporated in the one part. This is the first one. Second one, that is there are already the use case to draft a proposal to justify the TLV that can be used in the SRH, maybe not in the DOH or the hop by hop. This is the option header. Third one, I think the purpose of the SRH is just to propose this more capability of the network programming. I think based on this one, I think we propose this I think this is just at the base of this the TLV. The TLV is in the base draft. I think I think the TLV maybe in the future draft we can define more.
Just to add, like when Empress data plane was defined, not all use cases for label were defined. We are still defining use cases for labels.
Okay, empty microphone lines. I guess that's that's some progress. So I'm not quite sure how to. I think from up here it sounded like the TLV issue was sort of the biggest discussion topic here, and it's been discussed for quite some time. Personally, I don't quite see the difference between. All of these are containers, right, that carry TLVs that are not yet defined, like the hop-by-hop options or the destination options. I'm not quite sure I see sort of the significant difference between this option and the other ones we have. If I recall correctly, and I'm not sure I do, but I think with the discussion we had on limited domains, the working group did ask you to add the HMAC as an answer to the security concerns of crossing limited domains. So I'm uncomfortable of suggestions of going back on that. But if there are clear interoperability issues with the TLVs that are there, please propose text and clarifications, I think. And clearly, TLVs that don't exist, we can't specify, but I think that's fine, right? But I don't think we have any further ways of closing this now. I think as opposed to letting the discussion continue.
Yeah.
What do you think, Bob? During the week, yes. So we have asked the authors, with a strong encouragement to work through all these issues. During this week, we have a Friday session to summarize this. And, please, any issues you have, let's work through them this week. We have ample time between Monday and, today and Friday. So, yeah, super. Thank you, Darren.
And just wanted to make a note to those people with open issues who I've reached out to, get back to me and let's start getting to work. Thanks.
Super. Thank you. And Fernando, please come up. Yeah. Thank you.
Oops. Okay. So this is Fernando Gon presenting a document we co-author with Jan Source. The title of the document is Slack's reaction to renumbering events. There are a number of scenarios that can lead to the problem that we are discussing in our ID. We are going to focus just on one specific of those scenarios. So here we have a typical IPv6 deployment scenario in which you have a CPE router that does the HCP prefix delegation with the ISP, and it advertises a sub-prefix via Slack on the local network, okay? So the question is, for example, what happens when this CPE router crashes and reboots, for example? What happens in many of these scenarios is that when the CPE router comes back to life, it does the HCP prefix delegation again with the ISP. It might get leased a different prefix, and it will advertise one of the sub-prefixes of the newly leased prefix on the local network. Obviously, the hosts on the local network will configure addresses for the newly advertised prefix, but they will normally also keep the addresses and the routes corresponding to the now stale prefix. Obviously, the outcome of this is that since the previously configured addresses have become invalid or stale, any communication employing those addresses will fail. Obviously, depending on the scenario, if it's a basics-only scenario, communication might completely fail. If there is before connectivity and the application employs happy eyeballs, that might mean that the resultant traffic is IPv4, etc. There are a couple of deployments that might avoid this problem. There's a RIPE document. I don't remember the 690. Okay. Then RIPE 690 document about discusses the assignment of prefixes, and they actually describe a little bit this problem. And what they do in that document is recommend that ISPs lease stable prefixes. Well, persistent. Okay, persistent stable prefixes. The idea is obviously that if you always lease the same prefix to the CPE router, even if the CPE router crashes and reboots, it gets the same prefix, so nothing changes there. There are a number of reasons for which that might not be the case. With some of them you might agree or not, but I would say that at the end of the day, the thing is that you have deployments that employ dynamic prefixes for different reasons. Among others, there are ISPs that simply want to charge more for stable prefixes. Again, this is a deployment reality. Then you might say, well, this is right, I would do things differently. This is what we have. There's another thing that could be done to avoid this problem to some extent, is to have the CPE routers record the prefixes that have been leased on stable storage. So the idea is that when the CPE router crashes and reboots, it remembers what was the prefix that had been leased before, and the CPE router could somehow try to invalidate the prefix. That can be tricky for a number of reasons. First of all, if the reboots are frequent, the CPE router might have to record many prefixes, not a single one. Of course, assuming multiple reboots and dynamic prefixes. They might also need to advertise these prefixes for quite a while, the lifetime of the prefixes. Another thing is that even if you try to invalidate these prefixes, according to RFC 4861, valid lifetimes smaller than 2 hours should not be honored. So you can reduce or the preferred lifetime as much as you want, but not the valid lifetime, meaning that you'd keep these prefixes or the address configured for these prefixes for at least 2 hours. Another thing related with this is that there are implementations that enforce limits on the number of addresses that they will configure. So since the CPs cannot completely remove the addresses configured for these prefixes, well, you might unprefer the addresses, but you will keep the odd addresses. So if the reboots are frequent, then you might end up hitting the system-specific limits for the maximum number of addresses that can be configured. So how we think this should be solved? Our document discusses a number of things that might be useful. Essentially, and try to put it simply, the main mitigation for this problem that we propose in the document is to try to infer that when you receive arrays from the same router that you were receiving arrays before. These arrays include prefix information options for other prefixes and not for the previous one. Then you infer that these prefixes have become stale. Since we published this document, there was a lot of discussion. Actually, if you follow the 6-month discussion, it was over like 300 messages. And while we were discussing this topic yesterday, during and after the IEPG meeting, there were suggestions, for example, not to, let's say, completely act in response of these arrays. Again, arrays from the same router, they include prefix information options, but they don't advertise the previous prefix. But there have been suggestions, for example, such as in this particular situation, try to perform some kind of check before removing the addresses or the prefixes to check if these prefixes are valid or not. Eric Klein suggested, for example, to send a packet to your same address, but direct the packet to the next hop router. So if that packet bounces back, then that's an indication that the CPE router still has still considers the prefix to be there. In a sense, open receipt of arrays with other PIOs, we might want to do something about this. What's currently in the ID is to, first of all, unprefer the addresses and then to remove them. But there are other things that are possible, such as, for example, check with the router if the prefix is still there or not. Other things that might be of help. For example, RFC 4861 says that you shouldn't honor PIOs, or the lifetime in particular, not the PIO as a whole. You shouldn't honor valid lifetimes smaller than 2 hours. The reasoning in 4861 is to prevent the exploitation of these packets for performing denial of service attacks. Our view is that if you're going to trust the arrays, there are so many different, attacks that could be performed that just mitigating this particular one doesn't seem to be much sense to us. If we were to change this in 4861, then, for example, the CPE routers could actually, send arrays on the local network to actually disable, completely disable the prefix that has become stale. Another thing that we discuss in the document has to do with the lifetime of the prefix information options. For example, if you look at the default lifetimes, they are normally in the order of 1 month, okay? And in the context of RFC 8028, if I remember correctly, for multi-prefix networks, the idea is normally that you'd somehow tie each prefix to the router that advertises it. Why? Because if you have many routers and you're using many prefixes on the same network, if you just send packets from a prefix to some random router, they are likely to be egress filtered. So one of the things we discuss in the document is to cap the lifetime of the PIOs to the router lifetime. And the current version of the ID also suggests sending more frequent arrays, which, based on discussion among a number of folks, it's a no-go. But since it's in the ID, I'm mentioning this in this slide. Comments?
Tim Winters, UNH-IOL. So, my one question about this, 4861 allows for invalidating lifetimes that are less than 2 hours. So, everything we test, we give it a lifetime that's less than 2 hours. If you send it 0, it will invalidate it, right? It's only when you send it lifetimes greater than 2 hours that it won't let you drop it directly to 0, right? So, some people, for flash renumbering, basically drop their prefix lifetimes to less than 2 hours, and then they can invalidate all of those rules that have to do with lifetime are all based around the 2 hour. If it's longer than 2 hours, if it's shorter than 2 hours, you can just invalidate it using Slack.
Only preferred lifetimes.
I think it's both. I'd have to go back and look, but my memory of this is that it's both lifetimes, that if they're less than 2 hours, you can wipe it out, right? So this is to prevent, the deal here is for denial of service attack, you just have to set it higher than 2 hours, and then you won't run into this problem.
So, excuse me, you said that they don't, if you send the arrays with lifetime smaller than 2 hours, they just...
No, what happens with if you set it for more than 2 hours, and then you give it a value of, let's say, 5 seconds, it'll drop it to 2 hours. Okay, so if you had it set to 12 hours, and then you decided to drop it, you send it 5 seconds, it will drop it to 2 hours in some cases. Some of the implementations will do that.
Okay. Well, yeah, the thing is that either way, if the arrays with lifetimes smaller than 2 hours were honored, then that would allow, for example, the CPU routers that have recorded the least prefix on stable storage to actually disable the state prefix on the local
Right, and that's what you're going to have to put in there, some sort of text around that, because in the case of less than 2 hours, you don't really have this problem. In the case of over 2 hours, you have to do something, because that's going to be the problem.
Sorry, Richard Patterson. On that note, so we already have preferred lifetime. So I think that's what the document says around less than 2 hours. So valid lifetime cannot be reduced below 2 hours, but the preferred lifetime can. So with sending preferred lifetime of 0, we can deprecate the addresses, and that mostly solves this problem. What I think the suggestion to adapt 4861 to allow valid lifetimes to be 0. The only problem that solves is the one you mentioned about having too many addresses in the deprecated state bound to the interface. So for hosts that have too many, the valid lifetime would solve that. But that's the only thing it was the only thing it will solve that we can't already solve with preferred lifetime of 0.
There's two things. So on one hand, if you cannot, let's say, completely remove the addresses, you can hit the system limit on the maximum number of configured addresses. Then the other thing is that if you cannot completely remove the addresses, if you, for some reason, you might say it's unlikely, but you wouldn't be able to communicate with the new owner of the prefix.
Yeah, is that such a big problem that we need to update 4861?
I'm not saying it's a big problem. Yeah.
Andrew McGregor. On the reduced PIO lifetimes, I don't recall whether there is anywhere in the RFC, in any RFC, that it says that if you are redistributing a prefix that you have learned through either Slack or DHCP, that you should set its lifetime to somewhat less than half of the lifetime of the lease you have on it, but it really should. Sorry, I don't remember if when redistributing prefixes, there is something that says that you should set the lifetime to less than half of the lifetime of the lease you have on it.
No, I think that the only requirement that is out there is that the lifetime of the PIOs should never be longer than the lease lifetime. That's it.
They should really be less than half, because of the semantics of DHCP. And there is a similar thing with the previous point about invalidating prefixes with Slack. It has the same issue.
Mm-hmm.
Tim Joan. Just to echo what Richard said at the mic just now. Also, I do remember many years ago when we had the common problem of hosts forming a 6-to-4 address from Microsoft address sharing, people turning that on and not realizing the impact on the V6 network. We had a little daemon that sat in the network and basically sent out RAs with 0 preferred lifetime to essentially deprecate those things. I mean, in principle, you could use that kind of thing here, but it'd be a bit of a hack, and B, you never know whether there's another router that's issuing these things. So you could do something where if you saw a packet with a certain source address, to say, that's no longer a valid source, and try and deprecate it. But I think that the problem here is that there's lots of things you could do that would be pretty hacky. There's some heuristics you can apply, and there's at one end there's heuristics, at the other end there's hacky, and I'm just a little bit nervous that there's going to be some very more hacky things proposed here that are going to cause problems beyond that are worse than what we're actually trying to fix.
Well, I would say that, you know, in a situation in which you don't have the CPU router, you know, telling you that the prefix has become stale, you're somehow trying to infer that that's the case. You know, based on the conversations that we had, like, you know, yesterday and today. So, for example, in the ID, what we do is open receipt of a few arrays with the PIOs other than the previous prefix. First, we unprefer the address, so it's not that we remove it completely from scratch. And then when we receive a few more, what we do is we remove the addresses. But there have been other proposals, such as instead of reacting in that way, try to check the prefix, try to check whether that prefix is still valid, for example, by sending a packet to yourself, but forwarding it to the next hop router. So if it loops back, that's an indication that the prefix is still valid. So it would be like, if you want, like a more conservative reaction than the one that, you know, we have in ID, and that's perfectly fine.
So conservative certainly sounds good, and I think it would be good to document for any of these heuristics or whatever you want to call them, you know, the constraints that apply to them, whether it's for a single router situation, multiple routers, whether you're multi-homed or not.
Yeah, the other thing is what we do, even in what we have in the ID, is we only, let's say, unprefer or remove the address if it's being advertised by that single router. So we are considering the case in which multiple routers are advertising the same prefix. In that case, what we do is we kind of like disassociate the prefix with that specific router, but that doesn't mean that we are removing the address. So we try to accommodate the case where the same prefix is being advertised by multiple routers.
Okay, that's good.
Jen Linkova. So yeah, I'm also a bit concerned that we're applying kind of hacky workaround to deal with broken routers or administrative misconfiguration. So I think it's a bit too heavy a solution, especially taking into account it completely changes logic of processing arrays. When you do not receive some information, it does not mean it's active anymore. So you're basically suggesting totally changing the logic. So I think that changing the defaults of preferred and valid lifetimes totally does make sense. I believe we actually should have done it long time ago, because 7 days and 1 month, it's like, doesn't make any sense from operational perspective. I believe it should be something similar. So preferred lifetime by default should be similar to router lifetime. Valid lifetime should be, I don't know, twice preferred lifetime or something like that. So it definitely should not be a month. And this, I believe, would solve most of the problems. We should not actually introduce any upper limit, because you're saying cap to router lifetime. In data center environment, I might have 1 week preferred lifetime, because even if my router disappears, I still might want to have on-link communication. So I think we definitely need to change defaults. It would help. Regarding the problem of not being able to talk to on-link prefix after renumbering, I'm actually not sure how big is the problem for home networks. You most likely do not talk to your old prefix anyway much, right? So I don't think we really need to tweak the protocol to work around that issue. And another thing, shall we think about something like happy balls for source addresses? And if you have 2 addresses from different prefixes, you might try to do kind of happy balls and see which one works and use that one. It's actually also might help.
I think I'll cap the microphone lines with the people standing there now. Eric?
Eric, not Mark. So one thing that isn't clear to me, and this is not about what goes in the RFCs, it's about which devices do we think make sense tweaking, right? Is it fixing these routers so that they behave better? And is that something that we should write down sort of rules? And if we do, will they actually be updated? As opposed to saying, oh, let's figure out some workaround, hacky or not, where the host can actually be more resilient towards this, or are we going to end up doing both of them to deal with this stuff? It's not clear how much sort of energy to put into this stuff and where people are likely to fix their implementations, right? If we had a good feel for that, then we can sort of would be more fruitful to explore what are the best approaches for doing this stuff that move us forward, and sort of short term, things we can do short term as opposed to longer term, right, to make this better.
I'm Jim Metatir. Regarding the default lifetimes of the prefix, I think there's some probably confusion. I agree that the current protocol default is probably too long, but in this particular model, I suspect it doesn't help much because it's more likely that the router simply copies what was advertised from the prefix delegation. So I think if we want to change something, that should be the default setting of the prefix delegation lifetime, rather than the SLLC default prefix lifetime.
So Tim, do you want the last comments? Just one thing that Fernando and I spoke with each other about before this session was that since there's been so much interest in this draft, we could use the Wednesday time for the people interested in meeting in a smaller room and talk this out as well. I think, Fernando, you could send an invite for that. I think that's 13:20 on Wednesday. I don't know if there are any free rooms where we can, find a bar if nothing else. But Tim, do you want to say something?
Yeah, Tim Chan, I was just going to say maybe we can tease out what can be done here into at least 3 categories. One of just best practices and recommendations for operators. One is for sort of what implementers might do. And the third one is, are there actual changes to existing specifications that are needed? So maybe try and think of the different categories of things that can be done here.
Yeah, super. We had closed the mic, Bernie,
okay,
but
sorry. I'll send it to you.
yeah, super. And let's see if we do that Wednesday session as well, and we can bring these things up. Super. Thanks a lot, Fernando. And we'll squeeze in one more session today because Safar has to leave for family reasons on Friday. So we'll do that 5 minutes now. Thank you, Safar.
Yeah, so I'll go quickly. So this is the work that is done with different vendors and lead ops and as well as with academia. This work is started about 1.5 years ago. So I have presented it earlier at 6MAN at least a couple of times, and also a couple of times at Spring. So I believe everybody is very well aware of the work. And at the moment, there are deployment that exists, and there is also a draft that was published by Sataru this morning, and that was regarding former update to these deployments. So this draft has been deployed, at least in multiple networks, and additional deployments are coming. So from implementation point of view, there is a large number of platforms where we have shipping code for the draft, as well as there was the interop activity that was done, multi-vendor interop activity, and that activity result for that would be showcased in MPLS World Congress next month. In terms of summary of the draft, at the moment it basically just reuses existing ICMP mechanism for use cases of ONM in SRv6 network. It also defines the SRH flags, OBIT. The OBIT was initially defined in the SRH draft, but as part of the comments during last call, this got moved out of the SRH draft, and this draft actually defined it at the exact same location because there are hardware implementation that is using that bit today. It also defined 2 ONM SID, and the purpose of that SID is to punt the packet, either without timestamp or with timestamp. And it also defined use case for in-band O&M using SRH TLV. From a summary of use cases, it has ping for both end-to-end and segment by segment, trace route end-to-end and segment by segment, and or actually hop by hop and segment by segment, in-band O&M, and path monitoring. For the discussion on when O&M packets are piggyback in the actual data traffic, this draft makes use of SRH TLV, and it is very important to note that nodes, not all nodes that would be along the route for in-band O&M will be capable of processing TLVs or O&M TLVs. So for that matter, it is really up decision on the local SID, the definition of the local SID would know whether the local SID is able to or should process the O&M TLV. And if the local SID is such that the node supports it and it's defined that way to look into TLV, then the lookup to the TLV will happen. So this is as opposed to any other option that exists through either destination option or hop by hop. And this is why it's very important to keep that TLV and the use case for the TLV is properly defined here. There was a discussion to that effect earlier. From next step, because of the multiple deployment and interoperability status, we would like the 6-man to adopt this draft. There has been some discussion whether this belongs to 6-man or Spring, but I think it's very clear that this is really in 6-man because of the OBIT definition, because of the TLV use case. So we really believe that this is in 6-man. And I don't know if chairs had chance to talk about that, but I mean, I think that's, I think, pretty clear. So I would really like the working group chair to start the adoption poll and ask the room in terms of the interest in taking on this working group, taking on this work. And then once the working group taking on this work, then we will start working on it in a collaborative fashion, more collaborative fashion, and address your comments.
Okay. Yes, we have discussed that a little bit, and I think we'll hold off with any other draft until we finish the base segment routing document, and then we can do an adoption call on the mailing list when that's done.
Okay,
Super.
thank you.
Thank you, Safar. And traditionally we would have said see you in Montreal, but since we now have 2 sessions, we'll see you on Friday. The blue sheets, please. Can you pass those forward, please? Oh, you haven't gotten the blue sheets. Oh my God, that's a procedural failure. We'll see if we can fix that. Where are the blue sheets? The back, can you bring them up front here, please?
One very quick additional comment. One of the scheduled and not scheduled agenda things around PVD stuff is being presented in Interia later. So that's potentially of interest to folks in this room. So if you're interested in some of that work, head over there later.
So you sent an email. There's an email on the 6-man list on that fact as well, right? Yeah, super. Thank you. Let's see. So how do I exit this now? Oh, here. Oh, good. Thank you. Yeah.